Today, let's prove the product law of logs, which states that the log base b of some product of two things, x, y, maybe those are numbers, maybe those are expressions, equals the log base b of x plus the log base b of y, or namely, the sum of the logs of both things. But can we prove this? Well, of course we can. First, let's set the letter m to be the log base b of x. Let's also set the letter n to be the log base b of y. Let's keep in mind the exponential equivalence of these. M equals the log base b of x implies that b to the power of m equals x. And n equals log base b of y implies that b to the power of n equals y. Well, now let's take the product of some things, namely x and y, since our original law actually has the product of x and y in it. Let's see what happens. So, x times y implies that b to the m times b to the n, which through the product of powers law we can say is just equal to b to the m plus n. And so we can say that xy is equal to b to the m plus n. Okay, now let's take the log of both sides, since we're really concerned with the log of xy. So the log base b of xy should then be equal to the log base b of b to the m plus n. Well, we can simplify this by a really fundamental property of logs. What is the exponential form of this implying? Well, it says that, b to what power equals b to the power of m plus n? And of course, the only logical answer to this is that, b to the power of m plus n is the answer here. So this log actually simplifies to simply m plus n. And so the log base b of xy equals m plus n. Recall what we originally defined m and n to be. Well, m is the log base b of x and n is the log base b of y. And so the log base b of xy is the log base b of x plus the log base b of y. And so we've proven the product law of logs.